So C is all about sample space and events. And some of this is just your notation. So just kind of pay attention to how I'm writing things out. First of all, sample space is just the set of all possibilities. And a certain event is an outcome in the sample space that has a particular property. All right, so your sample space is always the universal set, U, and then the outcomes are the elements, and then events are subsets. So all of this kind of sounds confusing, so we're going to organize it, and it'll make better sense when we're doing the problems itself. So how we list the outcomes, we're going to look at a couple different ways that we can list the outcomes and organize the information. It's really the organization that will help you the most. And then we're going to use set notation using our intersect or union and use Venn diagrams to help us out. Okay, first of all, two events are complementary if exactly one of the events must occur. All right, so we say if A is an event, A prime is the complementary of the event, or we can say not A. Okay, so a normal six-sided die is rolled once when you roll the dice. So when we do our universe, we're going to use our set notation. So use your brackets. What are all the different, your sample space, all the different possibilities that you can roll on a six-sided dice? Just list each number. So the universe or sample space are all the different possibilities. A, they define A to be a prime number from these choices. So out of these six, how many of these are prime? Okay. The first prime number is 2. We don't start with 1. We start with 2 because it's the number and 1 are the only factors. So 2 is prime, 3 is prime, and 5 is prime. So out of the 6 numbers in the universe, only 3 of them are prime. So A prime, not A. Which ones are not prime? So we just choose the rest of them. Okay. Then it says draw a Venn diagram to. So our box is always our universe with all of the numbers, and we only have one event, A. So we label A. What is in A? 2, 3, 5. And then what is not in A, but in the universe? That's it. So there's only one event that we're talking about. That's why we just need one circle. So everything that's in A goes in the circle. Anything not in A, but in the universe is in the box. So that's one way that we can organize our information is with a Venn diagram. Okay, so illustrate the possible outcomes when 2 coins are tossed. First of all, using a 2-dimensional grid. All right, so the 2 different outcomes when you toss a coin are heads and tails. So I need to list heads and tails going each direction for the 2-dimensional grid. So this would be head, head. This would be tail, head. This would be head, tail. And this would be tail, tail. So a grid is another way to show all different outcomes. So all of these are just showing you how to list the sample space and to see all the different possibilities. A tree diagram, here's the coin. You either flip a head or a tail. So this is the first coin, then the second coin. This is where the first one is head. So the first is head, the second is tail. Well, let's do it this way. Head, tail. So then we follow the tree, and this would be head, 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 tail. So we're listing each separate event here, and then this is our sample space altogether. So tail, head, if you follow the tree, tail, tail. So then this shows in the first, and then this is the second. So that shows your sample space. Okay, so then if we've got all of our organized information, then we can start looking at the probability. Okay, so this says use a tree diagram when spinning the spinner. All right, so we're gonna spin it 3 times. So here we're starting out, and what's our probability? We're either gonna, and it doesn't really say, so it could say, we could say blue and white. The book says blue and not blue. Doesn't matter. Oh, I guess it does. I wasn't looking right. Okay. And so this is your first spin. Then we can go blue, white, blue, white. So this is our second spin. And then our third, blue, white, blue, white, blue, white, blue, white. All right, so then we're gonna follow our tree, blue, 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 white, then blue, white, blue, blue, white, white. Then we're gonna come down here. These are the 4 where we spun blue first. Then we have our white, white, blue, blue, white, blue, white, and white, white, blue, or white, white, white. So these are all of the different options. So we haven't even gotten into probability, because then the next step's going to be inserting our probability along the way and finding what's the probability of each outcome. So this says blue twice. And notice it doesn't say more than twice, it says exactly. It just says obtaining blue twice. So we're not going to do the first one because that's 3 times, but this has 2 blues, this has 2 blues, and this one has 2 blues. So 3 out of the 8 have 2